Today we're going to move on to section 10.5, which is apply other angle relationships in circles. So as we go through these next couple sections, you're going to have more rules that you need to keep track of. So far, we know that the measure of a central angle is equal to the measure of its intercepted arc, and we know that the measure of an inscribed angle is 1/2 the measure of its intercepted arc. We're going to add to that list today. In order to do this, I'm going to go through this warm-up because it's important that we can solve an equation that looks like this. I have 3x minus the quantity 360 minus x, all divided by 2 equals 70. I'm going to multiply both sides by 2 to start. So I have 3x minus 360 minus x in parentheses equals 140. The key here is to make sure you distribute the subtraction. This is 3x minus 360 minus negative x. Sometimes it helps to put a plus a -1 here and distribute that -1. We need to make sure that this becomes a plus x. Minus negative x becomes plus x. And then we can solve as usual from here. Combine your like terms. Add the 360 over. And divide by both sides by 4 to get x. You'll see some equations like this in the work over the next couple days. So here's our first rule for today. If a tangent and a chord intersect at a point on a circle, the measure of each angle formed is 1/2 the measure of its intercepted arc. Look at this diagram. I have a tangent, which has its point of tangency at A, and a chord, AB, which intersect on the circle. The rule says that when the tangent and the chord intersect at a point on a circle, the measure of each angle is 1/2 the measure of its intercepted arc. So if I look at angle 1, here's angle 1, formed by chord and tangent, it would be 1/2 of its intercepted arc. 1/2 the measure of arc ACB. Angle 2 is going to be 1/2 the measure of its intercepted arc. And sometimes it helps with these to draw out the sides and then draw the intercepted arc in between them. So here it would be 1/2 the measure of this minor arc AB. Now, one comment, we know that this is a linear pair, angle 1 and angle 2. So the measure of angle 1 plus the measure of angle 2 should add up to 180. They should be supplementary. And if we looked at the circle, I have 2 arcs making up that circle, arc ACB and arc AB. Those are the 2 arcs that each of those angles are 1/2 of. These 2 arcs make up the entire circle, so they add up to 360. So 1/2 of each arc should add up to 180. This makes sense. Another note, we've seen a special case of this before. We had a rule earlier in the chapter that said that when you had a tangent and you drew the radius to the point of tangency, it was always perpendicular. A radius is part of a diameter, which is a chord. This angle formed by a chord and a tangent would be 1/2 of my intercepted arc here. That intercepted arc is a semicircle. 1/2 of 180 is 90 degrees. So that fits with this rule. That's kind of a special case. The second theorem, when 2 chords intersect inside a circle, the measure of each angle is 1/2 the sum. 1/2 the sum is the same as the average of the measures of the arcs intercepted by the angle and its vertical angle. There's a lot of words in here. Let's look at what it means on the diagram. I want to find the measure of angle 1. Angle 1 is an angle formed by 2 chords that intersect inside of a circle. The rule says that that angle is going to be 1/2 the sum. It's going to be the average of these 2 intercepted arcs. The intercepted arc formed by this angle and the one formed by its vertical angle. So it's going to be 1/2 the sum of the measures of those 2 arcs. Oops, make that an arc symbol, plus the measure of arc CD. So for example, if this was a 40-degree arc and this was a 100-degree arc, to find the measure of angle 1, I would take 1/2 of 40 plus 100. 40 plus 100 is 140. Half of that is 70. These two angles, these vertical angles, have to be congruent to each other. They are both the average of 40 and 100. When you have a central angle, its two intercepted arcs are equal to each other, and that's why the central angle stays as being equal to the measure of the intercepted arc. The last rule we can have a couple different cases of. If a tangent and a secant, two tangents, or two secants intersect outside of a circle, then the measure of the angle formed is half the difference of the measures of the intercepted arcs. There's three different cases here, but these are all angles that are outside of the circle, and their rule is that they are half the difference of the measures of the intercepted arcs. With two secants, the picture looks like this. Secants are these lines that intersect the circle in 2 points. They're lines that contain chords. I want to find the measure of angle 1 where the two secants intersect outside the circle. It is half the difference of the intercepted arcs. And this is obviously going to be a positive number, so I need to take the larger arc, arc AB, minus the smaller arc. Half that difference will give me the measure of angle 1. When it's a secant and a tangent, diagram looks similar. Here's our angle 1 outside of the circle. I have two intercepted arcs here. I have one I've labeled as X and one that's been labeled as Y to make this a little simpler. So the measure of angle 1 is 1/2 the measure of the larger arc minus the measure of the smaller arc. Two tangents, here's our 2 points of tangency. Here's the angle outside of the circle. The measure of angle 1 is 1/2 the difference of the two intercepted arcs. Here I have the outer arc, that's X, and I have the inner arc, that's Y. Now, an important note on this problem, X and Y are related to each other because together they make up the whole circle. So in this problem, if I had this angle labeled as X, Y would also be 360 minus X because they have to add up to 360. So in some of these problems, you may only be given one value, and you have, if I was told you what X was, you could find this inner arc by taking 360 minus X. There's a set of 10 problems in a PDF for you to complete, and you're going to put your answers into a Google form and correct them.